Okay, in this section we're going to discuss ellipses. A definition is ellipse is a set of all points the sum of whose distance from two fixed points is constant, and we call those two fixed points the foci. So in other words, this point P lies on the ellipse if D1 is the distance from P to F1 and D2 is the distance from P to F2. D1 plus D2 will equal some constant K. And we can use this definition to derive the equation of ellipses. Now there's two major types. The foci are either going to be on the x-axis or the y-axis. By the way, we're assuming that the center of the ellipses is always 0, 0 in this section. This first case, where the foci are on the x-axis, that's going to be true whenever the number below the x squared term is bigger than the number below the y squared term. And it's really important that you have 1 on the other side. In which case, the vertices are going to be at plus or minus a0, and the major axis will have length 2a. The minor axis has length 2b, and the foci will be obtained, they're at plus or minus c0, they're obtained by using this equation, c squared equals a squared minus b squared. Now if you have the other way, if the foci are along the y-axis, then the bigger number will be below the y squared term. So that's how you tell whichever term has the bigger number below it. And also you have to have 1, don't forget about that. In which case the vertices will be at 0 plus or minus a, and the foci will be at 0 plus or minus c, and you still use the same equation, c squared equals a squared minus b squared. That relates the coordinates of the foci to the coordinates of the vertices to the coordinates of the endpoints of the minor axis. Anyway, one more thing here before we do some problems. Let's talk about the eccentricity. The eccentricity E is a measure of how circular the ellipse is. E is the ratio of C to A. So for example, if you have like an ellipse where the foci are basically on top of each other, that would mean that C is close to 0. If C is close to 0, that means the eccentricity would be 0 over A, which is close to 0. The other situation is, what if C is close to A? Now you have A out here on the end, right? If the foci are close to that, if C is close to A, then what happens there is, if C is close to A, then the eccentricity will be close to 1. Okay, so the closer the foci are together, the more circular it is, and the further apart the foci are, the less circular, the more stretched out it is. Okay? Okay, so if you wanted to graph this problem, you first have to get 1 on one side, so you divide both sides by 36. You get x squared over 9 plus y squared over 36 equals 1. And what you notice is that the bigger number is underneath the y squared, so you're going to have vertical foci, right? A would be 6, B would equal 3, and the way you find C is use c squared equals a squared minus b squared, which is 27, right? 36 minus 9 is 27. So that means that C equals the square root of 27, which is 3 radical 3. So what are the equations? The foci, coordinates of the foci, since it's vertical foci is going to be 0 plus or minus 3 radical 3. The vertices are going to be remember the vertical now, 0 plus or minus 6. And so you've got 6 here, negative 6 here. And then the endpoints of the minor axis, that's plus or minus b, 3 here and 3 here. The graph looks kind of like this. And the eccentricity would be what? E equals c over a, so it's 3 radical 3 over 6, which is radical 3 over 2. Alright, let's keep on going here. How about this one? Now this one, you don't have a problem with 1 on the right side, but you do have to write in the right form. Let's take that 4 in front of the y squared and write it as y squared over 1/4. Okay? So in which case, A equals Now this is x over 1. Now notice the bigger number is underneath the x squared. So this is going to be horizontal foci. A equals 1. B would be 1/2. And then remember the way you find c squared is a squared minus b squared. In this case, it equals 1 minus 1/2. 1 minus 1/4, I should say, which is 3/4. So c equals radical 3 over 2. So then the foci would be at, remember we're talking about horizontal foci now, would be at plus or minus radical 3 over 2, 0. The vertices would be at plus or minus 1, 0. And the eccentricity is equal to c over a, is radical 3 over 2 over 1, which is just radical 3 over 2. And the graph, or since these are so close together, let me make every 4 units 1. So this will be 1. This will be 0, 1 up here, okay? This will be 0, negative 1, 1, 1, 2, 3, 4. Then 1/2 would be 2 of them. I got this backwards, don't I? Whoops. Try it again. Since the major axis is the x-axis, let's try it one more time. So we got 1, 2, 3, 4, 1, 0. This is negative 1, 0, right? This would be, 2 of them would be 1/2. 0, 1/2. Whoops, what's going on around here? 0, 1/2. 0, negative 1/2. Anyway, so the equation looks kind of like this. All right, let's keep on going. Okay, let's look at this. So now we're just trying to find the equations. It might be nice to sketch a graph once in a while. The vertices are plus or minus 4, 0 plus or minus 4. So doesn't that tell you that you're going to have vertical foci, right? Or vertical foci, right, along the y-axis? The foci are going to be at 0, 2, and 0, negative 2. So the graph is going to look kind of like this. I'm just giving a rough sketch here. All right, so in order to finish this, all I need to know is b, right? A equals 4. So the way we find b, remember, c squared equals a squared minus b squared. So that means that b squared equals a squared minus c squared, which equals 16 minus 4, which is 12. I think that's all we need to do. So in other words, the equation is, it's going to be y squared over a squared plus x squared over b squared. Remember, since the foci are along the vertical axis, right, equals 1. So it's going to be y squared over 16 plus x squared over 12 equals 1. That's all we have to do. They didn't really ask us to graph it, but it is nice to draw a picture, isn't it? Let's keep going here. How about this one? This one says the equation left with vertices 0 plus or minus 6. Okay, well, again, we have the vertices along the y-axis, and the length of the minor axis is 4. That's telling us that this is actually easier. Look, this is 0, 6. This is 0, negative 6. And if the minor axis has length 4, this has to be 2, 0. This has to be negative 2, 0. Isn't that true if you know a and b? As long as the center is at the origin, you can actually write this. It's going to be y squared over a squared plus x squared over b squared equals 1 again. So you get y squared over 36 plus x squared over 4 equals 1. That's all you have to do. You don't really have to find the foci, do you? Okay, let's try this one. I want to find the equation of an ellipse with endpoints of minor axis plus or minus 2, 0. So that right there tells you that you're going to have foci on the vertical axis, right? And it goes to the point negative 1, 2. So it's going to look kind of, this is the ellipse more or less. It goes to the point negative 1, 2, something like that. So it's going to have the form y squared over a squared plus x squared over b squared equals 1, right? And we know b is 2, so b squared is 4, so we got y squared over a squared plus x squared over 4 equals 1. So how do we finish this? Well, how about using the fact that it goes to this point? When x is -1, y is 2. Let's plug the point in, we can find a. So we're going to plug in 2 for y, so you get 4 over a squared. We're going to plug in 1 for x, plus 1/4 equals 1. That says 4 over a squared equals 3/4. Let's see, when you cross multiply, you get 16 equals 3a squared. A squared equals 16 over 3. So now you can write the equation as y squared over 16 over 3 plus x squared over 4 equals 1. We can flip that over and say 3y squared over 16 plus x squared over 4 equals 1. You leave it like that. Or if you want to clear the fractions, you could say multiply both sides by 16, 3y squared plus 4x squared equals 16. That's another way to write the answer. Alright, we got time for one more. This last one's pretty hard. Okay, so this last one we want to find the equation of the ellipse with eccentricity 1/2 and endpoints of the minor axis 0, comma, plus or minus 2. So that tells us something. We got a minor axis going through 0, 2 and 0, minus 2. But this is a minor axis, right? So we're going to have to make it a little wider in the x direction, I guess. Something like that. So let's see, the eccentricity, remember what that is? E equals c over a, which is 1/2. And that says that 2c equals a. Okay? Furthermore, you know that the vertical axis is the minor axis, so that means the horizontal axis is the major axis. So the equation is going to be something of the form x squared over a squared plus y squared over b squared equals 1, right? Alright, so you know b is actually, b is 2. So what we know is x squared, x squared, x squared over a squared plus y squared over 4 equals 1, right? Because we know b is 2. All we have to do is find a. How do you do that? Well, we're going to use this fact, but what haven't we used yet? We haven't used the fact that c squared equals a squared minus b squared. So you could say c squared equals a squared minus 4. Isn't b equal 2? Furthermore, you could replace a with what? With 2c. So you get c squared equals 2c squared minus 4. So that means that, let's see, c squared equals 4c squared minus 4, or that 3c squared equals 4, right? So that says that c squared equals 4 over 3, c equals 2 over radical 3. Now, you also know, we haven't found a yet, but no, 2c equals a, so a would equal 4 over radical 3, right? Or that a squared equals 16 over 3. Alright, so let's put it all together. Then you have x squared. Actually, let's move this down just a bit. Let's move this down a bit here. Let's see. Let's write it as x squared over a squared, which is 16 over 3, plus y squared over b squared, which is 4, equals 1. And then when you flip it over, you get x squared, or 3x squared over 16, plus y squared over 4 equals 1. And if you wanted to clear the fractions, you could get that 3x squared plus 4y squared equals 16. There you go. Here we go. We'll see you later. Bye-bye.